So the next part of rational number is properties of subtraction of rational number. Okay, now in this property, as you know it, the subtraction is the inverse of addition, right? Subtraction is the inverse of addition while subtracting two rational numbers. So the rational numbers, the additive inverse of the rational number that is being subtracted is added to the other rational number. So you can do it like this, or you can do it in the normal way like we are doing, right? So the first property of rational number is the subtraction, just like addition. We already did it in the last class. So the first is, what is the first property?
The closure property.
The closure property. The closure property is the simple property. Simple, you have to do the subtraction with the two rational number. So suppose we have P over Q and R over S. When you subtract any two rational number, we'll get it the rational number only. So basically, if P over Q and R over S are two rational numbers, then when you subtract P over Q minus R over S is a rational number only. This is the format of this property. Same like addition. Now the first example, when I take the natural number example is, so suppose 7 minus 2. Both are the natural number. When you do the normal subtraction, you will get. Second is, if we take the any integers. So if we take integer, negative 5 minus any integer, suppose negative 1. So when you solve this, negative 5, negative will become positive, positive 1. So negative 5, positive 1 will be negative 4. Now this is the integer subtraction. Suppose the same thing we are doing with the rational number. So rational number, if the 1 over 2 minus 5 over 9. See, both are the rational number. This is positive rational number. This is also the positive rational number. When you subtract it, both the positive rational number will get it negative 1 over 18. I am not going to the depth of the calculation because as you know it, how to subtract it. Everyone know it, right? So negative 1 over 18 again a rational number. Suppose same thing we are taking with the negative rational number. Any other example with the negative value like 2 over 7, negative 2 over 7 and negative 3 over 8. When we'll solve this subtraction, then what will be the answer? Will you find it?
Yeah.
Find the rational number.
Wait, so you want me to like solve the problem?
Yeah.
Okay.
So the answer become negative 37 over 56. So now see, if negative rational number subtract with the positive rational number, so your answer will be negative rational number. Means it's a rational number only, right? So this is the concept of the closure property. Now come to the second property.
The Yes, I finished writing.
So the second property of subtraction is commutative property. As you know it, commutative word comes from order. So this is called the order property also. So what is the format of the order property? P over Q minus R over S. If you change the order, R over S minus P over Q. Now check. Will you get the same when you subtract it in the different order? So when you change the order, 100% you will get the change the answer. So suppose 7 will take the natural number like the last example. So 7 minus 2. When you change the order 2 minus 7 and you simplify it, you will get here 5. You will get here negative 5. See, both are the change. So this is not possible, right? So what we can say that subtraction is not commutative for rational number, even in any number, in natural number, even in integers. If we take negative 5, negative 1, as we have taken the same example. So negative 1, when we change the order, what will be our answer here? This is plus 1, this is negative 5. It will become positive, negative 4, and here you will get plus 4. See? So answer will be change, right? Answer will be change. So when you change the order, definitely your answer will be changed. So subtraction is not commutative for natural number. Subtraction is not commutative for the integers. Subtraction is not commutative for the rational number. So this property will not work in the any number system. Take the rational number example, 2 over 3 minus 3 over 7. When you change the order, your answer will definitely opposite. 3 over 7 minus 2 over 3. Both are the positive rational number. When you find it the answer in both, so this side, left side, you will get 5 over 21. And the right side you will get negative 5 over 21. See the answer. Just opposite. You will never get the same answer in the subtraction. Any number you can use it, but answer will be never same. Okay. So this is the commutative property. Commutative, the lower grade, I mean the third, fourth, fifth grade, we learn this property with the name of order. Now in the higher grade, we learn this property name is commutative. Commutative means if you commute from home to school and school to home, so the distance remains the same, right, in addition. But in subtraction, it will change. So the third property is associative property. The other name is associative property or associative law is group property. Okay, group. The difference is group property is the format of group property P over Q, R over S, U over V. See, we have now more than two rational number. One rational number, normal subtraction, we call it a closure property. Two rational number, we are doing with the change the order, we call it a commutative property. Associative, more than two or more rational number, when you subtract it, add it, we call it a associative property. And this property, if you change the order in group, basically, then this is the format of the associative property. Now come to the examples. So if we take the natural number example, so natural number is 7 minus 5 minus 2. Same, if you change the order, you can change order in any ways, okay? One way also we can make it in this, okay? So suppose P over Q, you can write it U over V in one parenthesis and R over S is different. So you can make it one more group, but so this is 3, it will become 4. Here is 2 minus 2, which is 0. So you can see here the answer is totally different. So this is also not work in the addition, the subtraction property, okay? This will not work. In natural number, integers, rational number, not work for any numbers, okay? Now I am giving one example for the rational number and then done. So the other example of rational number is, suppose negative 3 over 5. This is the negative rational number, 2 over 3 and 1 over 2. Always remember, whenever we'll solve this property, first of all you will solve this parenthesis, okay? After you will solve this. Now if we change the parenthesis in this order, then check your answer both the side, you will get the different answer, okay? So if we find this one, this parenthesis first, so this parenthesis will give your answer directly. I am doing, okay, 1 over 6, and when you solve this you will get negative 23 over 30. Now check the right hand side. Is it giving the same answer?
Well, LCM gets
Yeah.
15.
Negative 19 over 15, negative 1 over 2. When you solve this subtraction, we'll get it negative 53 over 30. Right? So now you can see it here. If we change the group, then you will never get it the same answer. So subtraction is not associated for natural number. Subtraction is not associative for integer. Subtraction is not associative for rational number. Basically, subtraction property of associative is not for any number system. Okay, understood? Subtraction property of 0. What is this? The result of subtracting 0 from a number is a number itself. Yeah, number itself. So suppose we are taking the rational number now. So P over Q, when you subtract with 0, you will get the number itself, right? So this is the format of the 0. Like we have done in the addition now, if you remember, the additive identity and additive inverse, okay? But the inverse of fraction. Now we'll take an example. When any natural number subtract with 0, we'll get it the same number. Same for the integers. If we take any integer, subtract with 0, we'll get the integer. Same for the rational number, 2 over 7 minus 0, we'll get it 2 over 7. So the conclusion is this: the result of subtracting 0 from a rational number is a rational number. Subtract from a 0 any number, integers, natural number, any number, will get it the number itself. Okay. Now come to the fourth and fifth property of addition. When you see it, then there is a property is additive inverse, additive identity and additive inverse. Here is subtraction, no additive identity and no additive inverse, because the inverse of subtraction does not exist as the identity element does not exist, because here is no additive identity, so here is no additive, additive identity is there in the addition, so there is a additive inverse also. In subtraction, there is no subtractive identity, so there is no subtractive inverse. So here is only 4 properties, which is closure, commutative, associative, and third is subtraction property of 0. That's it. So subtraction property done here. So first property of multiplication is same like addition, subtraction. The name of the multiplication property is
Closure property.
yeah. Closure property. Closure property is a simple. The rational number are closed under multiplication. It means that the product of two rational number is always a rational number. So P over Q times R over S, always give it the rational number. Any rational number you can take it, then it will give the answer rational number only. So this is the format of the closure property, just addition and subtraction. Now come to the questions. Suppose we are taking the any natural number. As you know it, any natural number multiply with the any natural number will get it the natural number only, right? Same in the integers. -7 times -2. When you multiply two integers, will get it integers only. So two negative integers multiplied will get it the positive integers, because here is two negative sign. Same we can do it in the rational number. 2 over 3 times 4 over 5. First of all we'll check it. Can we simplify here anything? If we simplify here, then it's okay. If not, you just multiply normally, as you know it. We have learned in the last grade how to multiply the rational numbers. So 2 times 4 is 8. 3 times 5 is 15. So numerator multiply with the numerator and denominator multiply with the denominator, right? So this is the concept of multiplication. We are taking one more example for the negative one. -11 over 12 and 5 over 2. Now check. Can we simplify something here? No, we can't simplify here. So you just multiply numerator with numerator and denominator with denominators. Now we have this. So the property says that the rational number are closed under multiplication. Why? Because when the product of two rational number is always be a rational number, or two natural number will give it a natural number. Two integers will give it a integers. Two rational number, when you product two rational number, is always a rational number. That's it. So closure property is. So the second property of multiplication is commutative property. When the product of two rational numbers remains the same even if we change their order. So commutative property, as you know it, we call it a order property also, right? So when you change the order, you will get the same number. So 5 times 4, if you change the order, will get it the same both the side, right? Same integers, -7 times -2. When you change the order, -2 times -7 will get it 14 both the side. So the simple conclusion is the product of two numbers or two rational numbers remains the same even if we change their order. Now take one example of rational number. So 3 over 5 times 4 over 7, right? Both are the positive rational number. If we change the order, then see, there will be no change in the answer, right? In the product. So 12 over 35, 12 over 35. So yes, when you change the order, the answer remains the same. Okay? Yes? Any confusion? So commutative property work in the multiplication part. So the third property of multiplication is associative property. As you know it, associated word means it's a group property. So when we have the more than two rational number, we call it a associative property. So associative work or not work, let's see. So associative, three or more rational numbers can be grouped in any order to find their product. So multiplication is associative for the rational number, right? Because if you make any group of the rational number, we'll get it the same answer. For example,
Yeah, we'll make
yeah, 5 times 2 times 3. So when you change the order, like 5 times 2 times 3, as you know it, first we will solve this part, right? So this is 6. 6 times 5 will be 30. The same, you will get 30 in the other side. That means yes, the associative property work on multiplication. Okay, now integers also you can take it. I am taking directly the rational number example. So suppose rational number example is negative 3 over 7 times negative 2 over 5 times 4 over 11. Now I am changing the group and see the answer. So when we change the group, two or more rational number can be grouped in any order to find their same product. Basically, the answer remains the same if you change the group. So when you find this, can I write the direct answer? So
Yeah.
24, yeah, 24 over 385. When you solve it, we'll get it the same answer both the side. Same product. 24 over 385. So yes, this proves that associative property work on multiplication. Okay. So the product of three rational number remains the same even if their order is changed. This is the conclusion. Okay. Yeah. So the fourth property of multiplication is multiplicative identity, which is important property of multiplication, like addition. In addition, we learned the additive identity, which was 0. Additive identity is 0. Now, see what is multiplicative identity. So, multiplicative identity is the product of a rational number and 1. Product of rational number and 1 will get it the rational number only. If you change the order, P over Q times 1, or you can change the order 1 times P over Q, then your answer becomes same, P over Q. So the conclusion is P over Q in both the sides. This is the format of the any multiplicative identity. Means natural number, integers. So if anyone asks what is the multiplicative identity, so your answer should be 1. Okay. If anyone asks what is the additive identity, so your answer must be 0.
0.
Okay. Yeah. So this is very important property. Now come to the example. When we take any natural number, so 5 times 1 will get it 5, or 1 times 5, when you multiply in the other order, then we'll get it 5. That means the product of any number and 1 is always a number itself. So 1 is called the identity element of multiplication for any number. Natural number, integers, but we are talking about in this topic rational number. So yes, rational number. So here 1 is called the identity element of multiplication for a rational number. Okay. So this is always remember. So now take it the integers. Negative 7 times 1 will get it negative 7. Now come to the rational number example. So 2 over 3 times 1 will give it 2 over 3. The same number. same rational
Yeah.
number. So 1 is called the multiplicative identity for rational number. If we take any negative rational number, negative 7 over 9 times 1 will get it negative 7 over 9. See, right? So the identity
Yeah.
will never change. Like our second name, right? Our surname. If we put your surname with any name, then identity will never change. You will be a same identity. So identity is like this, right? So now the second is, so the last fifth identity is property of multiplication is multiplicative inverse, which is this like do you know the reciprocals we have learned in the seventh the last grade,
Yeah.
even in the
That is
many
it.
grade, right? So yeah, reciprocal means you will flip the numbers, right? So what is the flipping? Like p over q, we will flip it like q over p, right? Yes, so this will work in this property, okay? So in this property, for every non-zero rational number, non-zero, there should not be zero there, okay? So the if you multiply the rational number with the reciprocal of this, then we'll get it the 1, right? How?
Yeah.
Like additive identity is 0. So when you additive inverse is like, additive inverse was what? P over Q is positive. So when you this positive, if you add with the negative, then we'll get it at 0 in addition, okay? But what is the difference in multiplication? When P over Q multiply with the reciprocal, then we'll get it 1. Basically the you have to find the additive identity in the additive inverse and multiplicative identity in the multiplicative inverse. So because multiplicative identity was 1, so you have to reach to the 1. So how you will come 1? When you reciprocal the number in the multiplication, then you will get 1. For example, take it directly in the rational number. So 3 over 11, right? What is the reciprocal of 3 over 11?
11 over 3.
Correct. So when you multiply 11 over 3, then you will simplify it. 11 will cancel, 3 will cancel. Simplify it, we'll get it 1, right? Now take it to any negative rational number. Negative 7 over 13, when you find the reciprocal of this, so it will become 13 over negative 7. When you simplify it, we'll get it 1. So this is the multiplicative inverse property, right? So basically you have to find the multiplicative when you find the multiplicative inverse, you have to find first reciprocal and then got the answer 1 easily. Suppose single number is here, negative 5. So what is the reciprocal of negative 5?
1 over negative 1 over 5.
Absolutely correct. Negative 1 over 5, which will give 1. Because negative 5 stands for negative 5 over 1. When you reciprocal it, you will get 1 over negative 5 or negative 1 over 5. So the conclusion is, there is no rational number which when multiplied by 0 give 1, okay? The rest 0 has no reciprocal. Okay, so 0 has no reciprocal. But for every non-zero rational number, P over Q, there exists a rational number Q over 1 such that if you multiply in the reverse order, then you will get a multiplicative inverse. So basically, you will say that multiplicative inverse or reciprocal. Suppose I am asking, what is the multiplicative inverse of 3 over 11? So your answer must be 11 over 3. Okay?
Yeah.
If I ask, what is the multiplicative inverse of 13 over negative 7? So your answer is negative 7 over 13. Yeah. Your answer may be you will flip the number and write the answer in the multiplicative inverse. That is the concept behind the multiplicative inverse. Yes, so now the next property is very important, which is distributive property of multiplication over addition. We have two format of distributive property. One is distributive property of multiplication over addition. The second format is distributive property of multiplication over subtraction. Because we have learned the addition, subtraction and multiplication. That's why we can do it distributive property easily here. Now write down the format of the distributive property. So distributive property format is P over Q times RS plus UV. Okay, this is why we call it a multiplication over addition. Distributive property of, because P over Q we will distribute with this and this. So distributive property of multiplication over addition. How you will do this? P over Q times R over S plus P over Q times U over V. This is the format. How come? This you will multiply first this. So this will be a part of this, and then addition sign is here. So you will put the same addition sign, and then the next is P over Q. Again you will multiply U over V and will get this part. Right? So distributive property is distribute like this. So P over Q you will multiply with R over S. This is this. Plus sign is common. Put it here. Then P over Q again multiply with the second part of the parenthesis, which is this. This is the format of the distributive property. Now distributive property is the very important property for further topics. Now come to the example directly. So I am taking the rational number example, okay, directly, or should I take it the natural number example first? If I take the natural number example, like 16 times 10 plus 2. See, all are the natural number. First, how you will do it? This multiply with this and this multiply with this, right? So 16 times 10 and plus sign is in between, so you will put the plus sign, then 16 times 2. Right? You can check in both the side, you will get the same answer. See, 16 times 12, which is 132, right? Sorry, 192. 16 times 12 will be 192. Exactly. Now, 16 times 10, first we will solve the multiplication part. As you know it, according to the PEMDAS rule, first solve it the multiplication part. PEMDAS, or you can say the BODMAS, okay? In USA, we call it a PEMDAS. In India, we call it a BODMAS. So 16 times 10 is 160 and 16 times 2 is 32. So when you add it, you will get 192. This is the natural number example. So distributive property is work like this. Okay?
Yeah.
Now, I am giving this example of rational number. Now, the next is rational number example. 3 over 4 multiply, under parenthesis we have 5 over 6 plus 3 over 8. Very careful when you solve these questions, because here is the multiplication sign, here is the addition sign, right? How you will distribute it, as you know it, how you will distribute it, this part and this
3
part.
over 4 times. Yeah.
So, how you will write it? 3 over 4 times 5 over 6. Then in between we have the plus sign, write it plus sign, again 3 over 4 times 3 over 8. Okay, always remember this. Now because of this side, if we solve the left hand side, then you will solve first the parenthesis, okay? So 3 over 4 times 5 over 6 plus 3 over 8, when you solve it, what you will get?
You'd get 15 and what's it called?
29 over 24, okay? 29 over 24. Okay, when you solve this, first you will try to simplify it if possible. Definitely 3 can be simplified, right? So the answer
Yes.
is
29 and 32.
yes, 29 over 32. Now come to this side. This side, because we have checked the sign first of all. This is multiplication sign, this is multiplication. So first you will solve this part, then add them, right? So now
Yeah.
first check, can we simplify something in here? Yes, 3 times 1, 3 times 2. Here can we simplify something? No, not possible. You just normal multiply here. Now the first part is numerator multiply with the numerator, so it will become 5 over 8. The next part is 9 over 4 times 8 is 32, right?
Yeah.
Now we'll make the denominator same and solve it. So when you solve it, you will get the same answer. What? 29 over 32.
Yeah.
Okay, when you solve it, 29 over 32.
2.
So yes, this will work. Distributive property of multiplication over addition in natural number, integers and rational number. All the numbers. The next is distributive property of multiplication over subtraction. So the only difference is this sign will change with the subtraction one. This addition is there, na? The distributive property of multiplication over addition, here is the plus sign in both the side. Now we can change with the minus sign. So this is the only difference in the changes of the multiplicative, the distributive property of multiplication over subtraction. So now try to understand the distributive property of multiplication over subtraction with the example. So if we take this example, 2 over 5 times 5 over 7 minus 6 over 15. How you will distribute 2 over 5? 2 over 5 you will distribute with 5 over 7 like this. Between we have the subtraction sign, put it the subtraction sign here. Then 2 over 5 distribute with 6 over 15. First, because these two are in the multiplicative form, so first we'll check it. Can we simplify here? Because if you simplify here, then it will be easier for the next step. So here you will take the LCM and whatever, how you will make it the denominator same, that's it's up to you. And then this, after this you will get it this, then this and this is in the multiplicative form. First check, can we simplify something? Yes. So we'll get it 22 over 175 in the left hand side. Now come to the right hand side. Because this is the multiplication, this is the multiplication, we will find it separately. Okay, so 2 over 5, 5 over 7. We can simplify 5 to 5. It will cancel. Only 2 over 7 is left. Write it down here. Same 2 over 5 times 6 over 15. Check first if this is possible for simplified. Yes, 6 and 15 we can simplify with 3. So 3 times 2 is 6, 3 times 5 is 15. Then whatever remaining part is here, you just multiply. It's numerator with numerator, which is 4. Denominator with denominator, which is 25. Now, because of here is the subtraction sign, you will again make it denominator same and find the answer. So yes, you can see both the side we have the same answers. So this is the property of distributive property of multiplication over subtractions.